The title of this objective is Factor four-term expressions by grouping. In number 1, we're going to factor this four-term expression by using a technique called grouping. I'll group the first two terms, and I'll group the last two terms. And now I ask myself, what's the greatest common factor of the first two terms? It's 2x, leaving me x plus 5. What's the greatest common factor of the second two terms? It's 3, leaving me again x plus 5. So now I can say, since I have 2x times x plus 5 and 3 times x plus 5, I can say that's the same thing as 2x and 3 times x plus 5, which is just a way of thinking about the distributive property. So we factored this four-term expression by grouping, and it matches letter A. Let's try another one. In number 2, once again, we're given this four-term expression. And we're being asked to factor this by grouping. So I'll group the first two, and I'll group the second two. Now the greatest common factor of the first group is 6x squared, leaving me x plus 1. And the greatest common factor of the second group would just be 1, leaving x plus 1. You don't have to write that 1 there, but I like doing that when I'm doing these problems. And now by the distributive property, I can say this is the same thing as 6x squared plus 1 times x plus 1. And again, that's by the distributive property, and that matches letter B. Let's try another one. For number 3, if I just go ahead and factor this right away by grouping, I can go through the same process and ask myself, what's the greatest common factor of the first group? It's 2x to the 5th, leaving x squared minus 1. And the greatest common factor of the second group is 3x, leaving x squared minus 1. So now by the distributive property, I can say that this expression is the same as 2x to the 5th plus 3x times x squared minus 1. Now, as I've said in earlier videos, when they ask us to factor, they imply for us to factor completely, which means we have to express this expression as the product of primes. Well, this first factor can still be factored further. I can take a greatest common factor out of it and say it's the same as x times 2x to the 4th plus 3. And this second factor is the difference of perfect squares. I can factor that to x plus 1, x minus 1. So even though I factored the expression here, I didn't factor it completely. I didn't express it as a product of primes, which I've done here. So the correct answer would be D for number 3. Okay, one more. For number 4, once again, I have a four-term polynomial I'm going to factor by grouping. I'll rewrite it first. Now I'm going to factor the first, I'm going to group the first two terms, and group the second two terms. Now when I do that, I usually put a plus sign right in between those groups because I have to include the negative sign with the third term, and I want to show that we're just adding these groups together, not multiplying them. So that little plus sign still shows that this expression is equivalent to what we originally were given. Now the greatest common factor of the first group is x cubed, leaving me 3x plus 4. And the greatest common factor of the second group, actually I'm going to factor out a negative 6, which is going to leave me 3x plus 4. And now by the distributive property, I can say that this expression factors to x cubed minus 6 times 3x plus 4. So that one's interesting because of this third term being negative when we do the grouping. And so make sure you leave the negative inside the parentheses and put the plus sign in between the groups.